I want to share our research on analyzing body asymmetry using 3D body scans and machine learning or in fields such as anthropometry, ergonomics, product design, and apparel design. Taking accurate body measurements is a critical step when designing products to fit human body, where we typically assume our body is bilateral symmetry. However, this convention overlooks the possibility that natural asymmetries could affect the measurement accuracy, pattern development, and ultimately product fit. And there's no scientific evidence out there as far as we know. On the other side, 3D body scanning enables precise investigation of asymmetry at both individual and the population level. In our study, we actually used both more traditional statistical method as well as machine learning method. They work together to tell a more comprehensive story. The purpose of this study is to examine body asymmetry systematically across multiple body sites and to explore its relationships with demographic variables. And also, we want to evaluate whether asymmetries are significant enough to warrant revisions in current measurement practices and to identify demographic factors. Do left and the right side body measurements differ at any measured body sites? Are there any significant correlations among pairs of right and left body measurement asymmetries across the body? And lastly, is the magnitude and or direction of body asymmetry associated with participant demographics? The data that I used for doing this project was the part of data I collected at the Kansas State University in 2018 as a part of North America, and collected over almost 300 sets of data. And so the type of data we collected include a survey where we collected demographic details, including age, sex, and dominant hand information. We collected a manual measurement. We manually measured their heights and weight, and use that measurement, we calculated their BMI. Also, we collected 3D body scans. There were 4 different postures, but for this study, we're referring to the data extracted from the A pose. From the body scans, we can extract as many kinds of measurements technically as we need, but we first defined the key body measurements. Those are the 22 pairs of body measurements we considered as key measurements from the perspective of pattern making. That's what we found. So regarding my research question 1, so what we found was supported the new hypothesis, which is expected. If not, then the whole practice of only doing patterns for one side of the body would be questionable. However, we did find something interesting. Okay, research question 2, the new hypothesis of research question 2 was rejected. Strong positive correlations including waist and the bust and the hip with upper thigh and the knee. We also found the moderate correlations including the bust to hip and the hip to calf, and surprisingly bust to elbow. Correlations among body asymmetry and the demographic or dominant hands. The new hypothesis of this research question were partially rejected. So when we use all the 22 pairs of body measurements to predict sex, the accuracy rate is actually 100%. In terms of the age, if we use whole body measurements to predict age, the success rate is at 75.6. Dominant hand prediction rate were as high as 80% if we use a whole body measurement. So we have quite a few here and there recommendations for practitioners, particularly pattern makers. Based on our study, we generally find no significant asymmetry, but there are certain areas requires extra attention. Certain asymmetry, they're interdependent. Particularly measurements around the shoulder area a lot of times require you to take measurements from both sides for accuracy. Asymmetry showed association with sex, age, and hand dominance.